In this RStudio video tutorial, we'll be looking at how to conduct a correlation analysis in R. A correlation analysis assesses the strength of a linear relationship between two quantitative variables. This test gives a correlation coefficient known as R as its primary output. If R equals 0, then there is no linear relationship between the two variables. If R is greater than 0, then one variable tends to increase as the other increases. And if R is less than 0, then one variable tends to decrease as the other decreases. R can range from -1 all the way up to +1, and larger values, not necessarily positive values, but closer to the extremes 1 and -1, indicate that there is a stronger relationship between the two variables. So the first thing we're going to do is read in the data frame for today, which we'll call wine. This data frame contains information about various characteristics of wine. Let's briefly look it up with the head function. We see one categorical variable and 4 continuous variables, all of which are numeric continuous. So for correlation analysis, we're going to want to choose one of the numeric variables. For this, I will choose flavonoid content and phenol content of these wines. So in order to do this, I'm going to use the function core.test and provide it with the two vectors I want to compare. So these are flavin, and wine phenol. Here we see a correlation coefficient, or R, of 0.86, which is extremely high, and a p-value of less than 2.2 times 10 to the negative 16, which is almost as low as R can go, as R's built-in calculator can go before it hits 0 and can no longer take more digits. So while this is not a very precise p-value, it is definitely extremely, extremely small, indicating that this is a highly significant result. We also see a 95% confidence interval for this correlation coefficient, which ranges from 0.82 to 0.897, or around 0.9. So from this analysis, we see that there is a very strong relationship, strong linear relationship between flavonoid content and phenol content for this group of 178 wines. However, we do not have any predictive power from this. We cannot say specifically when one of these variables tends to increase by 1, we can predict the value of the other variable. In order to do that, you will need to do a regression analysis. This correlation analysis only tells you the strength of the linear relationship, not any predictive power for the variables at hand.